creating functions that work in the pipeline. In this nugget, we're going to take functions one step further. We'll start with a review of why the pipeline is important and how it's intended to work with multiple objects simultaneously. We'll use that information to build a pipeline function. That's a function that can take input from the pipeline, process all of those objects as a group, and then put more objects in the pipeline so that something downstream can work with it. We'll look at how to get that output from the function into the pipeline, and we'll look at an example of converting a simple function, that'll be our ping host function from the previous nugget, into a more powerful pipeline function. Let's start by looking at a problem we had with the previous ping host function we wrote. This function is designed to take one computer name as input, and then it pings that computer name and outputs either a true or a false. What's difficult for us to do here is to write a command like get content, get a bunch of computer names, and then pipe that to ping host, and let's say only have those computer names which are pingable come out the other end. And those could then be piped on to another commandlet, such as get wmyObject or another one. So the way we've written our function right now, that's not possible. Instead, what we'd have to do is say something like names equals get content computers.txt. This would get all of the computer names into that names variable. We would then have to go through each one using a for each loop. For each name in names, we might then ping host name. We might even make that part of a bigger construct. Maybe if ping host name was true, then we'll go ahead and do something like connect to WMI. You can see that this is a much more sort of script-like, a much more complicated construct. It requires actually 6 lines, 5-6 lines of code, rather than just the single pipeline command that we could run if we were able to write this differently. Well, that's really where Windows PowerShell's pipeline excels, and it's really where we want to kind of be when we're writing our own functions. We want to get a bunch of objects, pipe them to some command that does something with those objects, maybe filters out the ones which are not pingable, and then be able to pipe those on to something else, so that all of our commands live in this chronological pipeline, and we're just piping objects from one command to another. The ideal way to use PowerShell is to stay in that pipeline model as much as possible, as opposed to going to a more scripting model. Now, it's not that scripting is bad, but it certainly requires a little bit more effort on your part. There's more actual typing involved. It's certainly building a function that has to be used in a script rather than one which can be used in a pipeline means it's a little bit more difficult for someone who's less skilled to use that function. They have to be able to write a script, as opposed to just plugging it into a more simplified pipeline. So there's a lot of advantages in using the Windows PowerShell pipeline, and fortunately, Windows PowerShell lets us build scripts that can actually work right in the pipeline. Makes it easier to distribute those scripts, and it makes it easier for other people to reuse those scripts for different purposes. So to get started with that, let's open up a fresh editor window and get a fresh script going, and look at what goes into building a pipeline function. Now, you've already seen a simple function in the previous nugget. Starts with the keyword function, and then the function gets a name. And then we've got the curly braces. Now, in a normal function, all of your code would go inside the curly braces. In a pipeline function, it works slightly differently. We're going to start by creating a named script block called begin. We're going to create a second named script block called process, and a third one called end. The only code that's allowed inside this function must be inside one of these 3 script blocks. You can't have any code outside these 3 script blocks. That's one of the rules for a pipeline function. Now let's look at how we plan to use this. I'm going to want to run a command like getService. I want to pipe it to my doSomething function. So I'm going to get a bunch of service objects and pipe them to do something. DoSomething has got to understand that it's going to be getting multiple service objects. And that's what this 3 script block structure really allows us to do without any extra work. Whatever's inside the begin script block will run first. It runs once before any pipeline objects are processed. Now in reality, you might use this script block to open up a database connection or check to see if a particular file exists. The end script block will run once after all pipeline objects are processed. So this might be used to close a database connection or add a footer to a report file. The process script block will run one time for each pipeline object. And in here, the $_ variable represents that pipeline object. So if we pipe in 36 objects, the process script block will run 36 times, and the $_ character will be the current pipeline object each time the process script block executes. So let's see how we might use this in a simple method. We're going to write host. Here is a list of service names. In the end script block, we'll write host. That was the end of the service names. And in the process script block, we're simply going to write host $_name. So we're not doing anything complicated. Ideally, what we should see is here's a list of service names, and then each service name will be listed, and then that was the end of the service names. So let's run this, and that's what we got. Here at the top of the output, you can see here's a list of service names, and then all of the service names are listed one at a time, and then that was the end of the service names. Let's see it again in a regular shell window. Same thing. Here's a list of service names, then the process script block ran once for each service that was input, and it output that service's name. At the very end, the end script block executed and displayed that was the end of the service names. So this is just a really simplistic way of building a function that works inside the pipeline. Again, it's designed to take multiple objects as input and then do something with each one at a time in the process script block. You don't have to write a for each loop or anything else. The process script block actually takes care of enumerating through the pipeline input one object at a time. So this is a very, very powerful way of taking a bunch of information and working with it, but without actually having to work with the group yourself. You only have to work with one object at a time, represented in the $_ variable. Now we talked in a previous nugget about how we need to output things from functions in order to have them work correctly. There were three options. Write host, which is what we've used here, that writes directly to the console window. There was write output, which writes to the pipeline, and there was return, which writes one value to the pipeline and then exits the function. Well, clearly we don't want to use return. As soon as we use return, we exit the function completely, and we're not going to continue processing objects. So here we've used write host, and let's see the impact of that if we take the output of do something and try to write it out to a file called service_list.txt. So when I run this in an external shell, now let's change to the root of the drive and get whatever's in service_list.txt. Well, nothing's in service_list.txt. And that's because we used write host. GetService got a bunch of service objects and put them into the pipeline. Do something took those pipeline objects, did something with them, but it never output any objects to the pipeline. Instead, it was writing directly to the console window. So when do something completed its execution, there was nothing in the pipeline for outFile to put into the service_list.txt file. So let's change this to just use write output in the process script block. We'll run this again. This time, notice that only the begin and the end script block showed up on the console. Everything else went to the pipeline. And so the pipeline ended in outFile. So let's take a look at that file of ours, service_list.txt, and there's all of the service names. So you can see that this information and this information were written directly to the console window. The names, however, were written to the pipeline. Outfile took those names and put them into a file. That's why they never displayed on the screen. Outfile itself didn't produce any output. So remember that the only way we see something on the screen is if there's something in the pipeline at the end for outDefault to pick up. Well, outFile consumed all of the input objects, didn't output anything, so there was nothing in the pipeline at this point, and so nothing was displayed. If we change all of these to write output, and then run our script again, nothing appears in the console window, because nothing was in the pipeline at the end of the pipe on line 21 of our script. But if we display the contents of servicelist.txt, we can see that all of the information did in fact make it into that file. There's the begin script block, there's all the script names, and there's the end script block. Now here's a fun little trick you can use. Instead of outFile, let's end this command line in tObject. We're going to give this the same file name, servicelist.txt. tObject is designed to write objects to a file and to take those same objects and put them down the pipeline, so that there will be something in the pipeline at the end, which means there will be something for outDefault to pick up and display in the console window. So just to make sure this is fair, I'm going to delete servicelist.txt, close this window, and run this script. So we did see everything in the command line, and if I type servicelist.txt, everything also went to that file. So tObject is a nice alternative to outFile if you want the objects to go to a file, but you also want them to continue on down the pipeline so that you can do something else with them. Now let's go back to our original ping host function. We'll close this other one here. So we're starting fresh. Okay, this is where we were. Again, we were taking one item as input. We want to convert this function so that instead of just taking one item as input, it takes a bunch of computer names. So let's start by getting rid of this input parameter. We're not going to need the input parameter. Instead, we're going to give it input from the pipeline. We want to be able to run get content cdemo computers.txt, and then we're also going to jump in there right now and make sure that we have that file. Computers.txt, good. Let's change it from these to some other names. Let's put nuggets2, which is not available, and then we'll put nuggets1 again, which is available. So we should have 1, 2, 3 computers which are available, and a third one which is not available. So we'll save that file and close it. So what we want to do is get the content from that file, pipe it to ping host, and then see what comes out the other side. So we need to start with a begin script block, a process script block, and an end script block. Technically, if you don't use the begin and end script blocks, you don't have to include them. You can just leave them out entirely. I always like to put them in just so that I can sort of see that this is complete. And we need to decide where this code is going to go. It cannot stay here. It cannot stay outside one of these three script blocks. And we want to put it into the process script block. And just to keep things kind of neat, because this is inside a script block, I'm going to highlight it and press Tab to indent it so I can tell that that code lives inside this script block. And the only other change we need to make right now is to change $computer, which is no longer being populated, with $_. That's the variable that will have our pipeline input, so it will contain our computer name. So we're going to try and ping the computer. If the ping was good, we'll output true to the pipeline. Otherwise, we'll output false. So let's see what we get when we run this. True, 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 true. Well, it looks like that nuggets2 is still online. Let's go in and make that a little bit more interesting by putting in one that we know is not available, saving the file, and seeing if it makes a difference or if we just have a bug. True, true, false, true. Okay, well, we succeeded in the first step of our conversion. The only problem we've got at this point is that on the output side, I don't remember what computer name goes with true and what computer name goes with false. So instead of outputting true or false, let's change it around. If the ping is good, let's just output the computer name. If the ping is not good, let's output nothing. That way, the only thing that comes out of this pipeline function are the computer names which are pingable. A bunch of computer names go in, and only those pingable ones come out. Let's run it again. Nuggets1, localhost, and Nuggets1. It skipped over the computer that's not here, that's not currently available. So that's perfect. That means we can take, as a next step, get WMyObject, Win32 service, from whatever computer names we want to. In fact, because there are more than one computer name being sent along the pipeline, we would probably want to wrap this in a for each object. And then we'll use $_, which will contain the computer name. So we're inputting a bunch of computer names, filtering out those which are not pingable, taking each one that was pingable, and retrieving a list of services from each one of those computers. So let's try and run this now. Great, we got a list of services from each computer which was pingable. You saw the little pause there in the middle where it was actually pinging that third computer which was not available. If we want to see that output in a little bit more condensed form, let's choose a smaller WMI class so that there will be a little bit less output, and we'll run this again. Great, so we got 1, 2, 3 sets of output. 4 names go in, 3 sets of output come out. And that means we didn't waste time trying to connect via WMI to that computer which isn't available. It only takes the ping a second or two to figure out that a computer is not reachable. It takes WMI about 30 or 45 seconds to figure that out, and when you run into a computer that's not available, you're going to get an error message. So by pinging them first, and by only attempting to connect to the ones that are actually pingable, we sort of reduce the amount of time we're left waiting. Let's go ahead and save this as pinghost_pipeline. So this is how to create a pipeline object, a pipeline function that can accept multiple different pieces of input from the pipeline and then produce multiple pieces of output for the pipeline. We start with a begin, we have an end block, and the process block does all the heavy work. Within the process block, $_ represents the pipeline input. So a bunch of computer names came in, let's say 4 of them. The process script block ran 4 times, once for each pipeline input. Each time it ran, a new pipeline object was placed into $_. Write output was used to put output into the pipeline that was consumed by the next commandlet in the pipeline. In this nugget, we looked at functions that are designed to work within the Windows PowerShell pipeline. We looked at why the pipeline is important for its ability to work with multiple objects simultaneously. We built a simple pipeline function that used a begin, process, and end script block. We looked at how to get information out of that function and into the pipeline so that some commandlet or function downstream can consume it. And we wrapped up by converting our simple ping host function into a more powerful pipeline function that does the same thing but is capable of working with multiple objects simultaneously. I hope this has been informative for you, and I'd like to thank you for viewing.